afternoon, everyone. Welcome to the AIY introduction session. How's everybody for I/O so far? Everybody had a good lunch today? Yes, okay, as you can see on the screen, the name of this session is called Introduction to AIY. Well, what is AIY? AIY is a new line of product Google makes for developers like you, makers all around the world, to make applications for artificial intelligence by yourself. That's the name of AIY, where that came from. Today, join with me, my colleagues in developer relations. My name is Bill Luan. I have Dushan, Sebastian joining me. We will give you a full introduction of the current AIY product line. So before we start, let me introduce my colleagues. So Dushan.
Hey, thank you, Bill. Hello, everyone. My name is Dushyant. I'm part of Google's developer relations team in India. I'm really excited here to show you some amazing demos on AIY Voice Kit. But before we start, I'll invite Sebastian to give you a quick overview of what is AIY and kind of set the context for this talk.
Thank you, Dushyant. So thank you very much for being here in person or watching this on YouTube. I'm Sebastian with this very complicated last name. I've joined Google quite recently, just about 11 years ago. And with my teams, what we do around the world, especially in emerging markets, is we help developers and startups build better mobile and web applications. Today, I want to talk to you about AIY. But before this, let's talk about DIY, do it yourself. So do you know what this is? It's not a UFO. It's actually a musical instrument, which makes very nice sounds. But no, it was not invented in prehistoric times. It was actually created in the year 2000 in Switzerland. Switzerland is actually the country where I'm officially based. Well, that is when I'm not in one of the other UFOs, which we call planes, because I travel quite a bit to visit my teams. Do you know what this is also? It's a window into DIY culture. Let me take you through a very brief history of humankind's appetite for DIY. And if you read the book Sapiens, A Brief History of Humankind, you'll know what I'm talking about. Our human ancestors were already building tools, as probably you know, weapons, instruments, using stone and wood. Now, if we skip a few generations of humans, we're still using wood to create things. This is one of my brothers, Matthias, and my sister, Lydia, some 30 years ago. And I'm sure you or your siblings did the same thing, tinkering with stuff or everything you could lay your hands on. Now let's fast forward to what I call the electronics age. Do you remember in the 90s how desktop computers, I'm not even talking about laptops, but desktops were so expensive? Who among you, show of hands maybe, to see who built computers with their, with spare parts? Yeah, I did that too, quite a few of you. And I'm the only one who's too old for this. On this animated image, you can see how I've used an overhead projector and a dismantled LCD screen to build a cheap homemade video projector. But then obviously, my mom got annoyed because all the electronics were everywhere in the living room. So she said, go outside, you need some fresh air. Okay, so I went outside, and that's me reusing garbage bags. $1 of garbage bags to build a solar balloon. It can almost lift me up. Not quite, but I'll get there one day. But the appeal of electronics was just too strong. So my siblings and I got back inside, and one of my brothers, the other one, Florian, started tinkering with 3D printers, homemade 3D printers. This is my other brother, the one on the right. On the left is actually a photo in the museum. As I said, DIY is in our DNA from very, very early on. It's also in Google's DNA. 4 years ago, you may remember a Google engineer from the Paris office, and I mentioned Paris because I'm actually French. And this engineer came here at I/O to show the VR platform he had built using cardboard during his 20% innovation time. Since then, this has become, 2 years ago, what we call the Daydream VR platform at Google. Here's what's interesting now. The maker culture is all about hardware on one side, physical objects, and on the other hand, software. This combination of DIY culture with a hacker culture. You may have heard of Maker Faire since 2006. You may have makerspaces around you, and if there's none in your city where you live, then why don't you start one of these makerspaces? The great thing about this maker culture is that you learn through doing, with your hands. You make mistakes, so what? Doesn't matter. That's a very good way to learn. to try new things and learn from each other. Figure out new applications that you can create with that technology. It doesn't matter what your background is. In fact, it's even better when you can mix and match different domains to find new applications of the technology. Now let's take a look at what has happened in the past few years. You now have microcontrollers like Raspberry Pi. The cloud has become cheaper. Lithium batteries have become cheaper. Did you know that lithium batteries, their cost has decreased by 80% in 8 years, over the past 8 years? And I'm sure you've heard about AI, artificial intelligence, especially since yesterday, right? And concepts like machine learning, deep neural networks. It sounds complicated, right? It doesn't have to be. It doesn't have to be. And this is why, with AIY, do-it-yourself AI, artificial intelligence, that we introduced last year, you can have fun. Because the idea of this maker culture is, before anything else, to have fun. Using, in this case, artificial intelligence, we want to put AI literally in your hands so that you can solve real problems. Our AIY kits are open source. They combine hardware and software, and they integrate AI directly on the device themselves. The essence, as I mentioned previously, is to keep it low cost, using readily available components that you can find almost anywhere on the planet. And the kits are very easy to assemble. Duchamp, how long does it take to assemble one of these kits?
15 to 30 minutes.
15, 30 minutes. Okay, let's say 1 hour, because my mum's going to say I'm very clumsy. Thank you, Mum. I know she's watching. So let's say not more than an hour to assemble these kits. Duchamp and Bill, right after, in just a few minutes, will demo some of these kits to show what you can do with them. So the voice kit and the vision kit. But stay with us. In the coming weeks and the coming months, there'll be more to announce in that space. Now let's take a look, and I'll finish off with this, at what some of you have already created. In this example, I'm going to show you in just a few seconds, a 16-year-old with no programming experience has managed to come up with the following use case. Let's play the video for just about 20 seconds.
Shop for New York Yankees baseball hats. So what's actually happening now?
Woo!
So she just said done, right?
Yep.
Okay.
So what actually happened was that when it said done, it's just sent links to my email
Okay.
after finding it on eBay. So it'll find results online, send links in an email to me, and I'm going to receive those so then I can quickly click and buy something.
So what happened here with Lawrence and the high school kid was shopping for a product. I don't know if you heard at the beginning. I'm shopping for some baseball caps, and was searching on eBay for results which were emailed right after when the device said done. So let me take you through the code. It's just, if you heard at the beginning, I'm shopping for some baseball caps, and was searching on eBay for results which were emailed right after when the device said done. So let me take you through the code. It's just, if you heard at the beginning, I'm shopping for some baseball caps, and was searching on eBay for results which were emailed right after. Through the code. It's just, if you heard at the beginning, I'm shopping for some baseball caps. Through the code. It's just, if you heard at the beginning, I'm shopping for some baseball caps. You may remember in the video that all the results are sent over email. Here's the code. We're gonna go through each result, the first 3 lines of the code up there, and format all this in an email. You can recognize, right? Even if you're not an experienced programmer, like something like from to subject line. That's it, nothing more. The last thing we do is just connect to the server, the email server, and just send the email and get the device to say, done. That's it, there's nothing more. You can literally copy and paste that code, it will work. Now it's your turn to do things with AIY, and if you're not inspired enough, I'll have Duchamp now to come on stage to do a demo with a voice kit. So thank you very much for listening, and welcome Duchamp back on stage.
Thank you, Sebastian. My name is Dushant. I'm part of a developer relations teams at Google. And like everybody, we all are excited about the possibility of AI has in front of us, correct? This only becomes more meaningful and more impactful when all of us kind of have an access to this wonderful platform. At Google, we have been sharing our work and advancement in the field of artificial intelligence by building products, sharing through our research papers, and now with the AIY kits, we are taking to even more people in a more playful way. Yet, it is strong enough for you to solve some really good problems. So let's see how we can kind of solve some of those things. And when we are thinking about this kit together, we're thinking, what makes sense, correct? What would be a right way of putting this in front of people? And of course, voice was one of the things that was very evident, correct? We all like talking. Imagine if we have a power of playing around with a voice, how fun it would be. Sundar did mention in the keynote yesterday about WaveNet, correct? How you can kind of create different voices. So in this demo, I'm just going to talk about the capabilities of AIY Kit with Cloud Speech API and Google Assistant API. But of course, there's much more than this. So the voice kit was launched sometime mid last year, if I'm not wrong, and it had got a lot of attention. The voice kit basically has a combination of few software and some of the hardware there. It was marketed along with Raspberry Pi Foundation to kind of see what are the feedback we can get from the existing maker community and try to improve our offering. We launched the second version of Voice Kit sometime in January to kind of incorporate all those feedbacks and make it all in a one-box component kit. So that's what you get today. If you go to AIY website and look at Voice Kit, this is what you'll probably find there. But what does the kit contain, correct? From a hardware point of view, it has Raspberry Pi Zero. It has Voice Bonnet, which is basically a piece of hardware which understands which does a lot of audio processing for you. And the Voice Bonnet has different components. It has a mic, it has a codec, microcontroller, general purpose input-output, and an arcade button to basically kind of give you visual indication of what's happening with your voice kit at any point of time. And from a software point of view, it basically runs on Raspberry and Linux, correct? It uses Google Assistant API and uses Cloud Speech API. But of course, you could do a bunch of things with that. This is just scratching the surface of the voice kit. So how can you get started? Very straightforward. Think of it as a three-step process. Step 1 is in terms of assembling the kit. Step 2 is setting up your device. And step 3 is now you have set up everything, you could kind of go ahead and build some of solution by yourself. So if you open the kit, this is what it looks like. First thing, ensure you have all the right components. Like you have a cardboard, all the different hardwares that is mentioned on the website. Just verify that you have all those components ready with you before you start assembling together. Once you verify, the next step what you need to do is kind of build an engine. Think of it as building a car, correct? You're building an engine. So putting Raspberry Pi and your Voice Bonnet together. Once you kind of put the engine together, then now you're building a chassis, correct? So it's a kind of structure for your car or structure for your voice kit. So you basically take it cardboard and kind of give it a structure of a speaker. Once you build the cardboard, then you put the engine inside it. You put the kind of Raspberry Pi and Voice Bonnet inside it. That's it, correct? It's super easy, super fun. For me, when I tried first time, it took somewhere around 15 to 20 minutes. But I'm sure you guys are much advanced than me, and you could kind of try to even faster. The key here is not to do fast, but kind of do it in a nice, fun way out of it. So yeah, that's it. You kind of assembled your voice kit. Step 2 is basically set up your device, correct? At this point of time, what you want to do is that now I have my device or my voice kit is more or less kind of in a nice shape and form. Let me kind of give a voice to it. Let me see if everything is working fine. So I have a already built voice kit here. And I'm going to switch back to my voice kit and see if everything is working fine there. So before you start, you want to kind of ensure that you have everything running for you. So things like, let's say you're connected to network. This could be either a wired network or a wireless network, or if you're tethering from your phone, just ensure you have some sort of a connection, because a voice kit needs to be connected to internet. Underneath it's using Google Assistant and Speech API for recognition purpose. Let me see if I'm online. Cool, looks like I'm all set from an internet point of view. Let's see if my audio is working fine, or the kit audio is working fine.
Front, center.
Seems okay. Let me see if it recognizes my voice. Testing, 1, 2, 3. Testing, 1, 2, 3. Seems to be okay. So now I'm almost set, correct? The good thing is that Voice Kit comes with some of the pre-built demos as well. It's good to kind of see if those are also working fine before you kind of start building yourself. So if you go to the Py directory and look at Python voice examples, which is here, and I'm just gonna try this library demo. Hey Google, what's the time right now?
It's 1:50.
Thank you. So you could try a bunch of things. I mean, what I was doing is that I was just testing if things are working fine. Now, of course, you could, at this point of time, ask a bunch of other questions. Now, things are kind of, seems to be okay. Let me see if we could, if we can build something or not. Let me go back to presentation. Can we go back to slides? Yeah. So our device was kind of, so it's always good to see if device is working fine before you kind of start building by yourself. I have built a typical shopping experience. Hopefully it should work fine, but let's see. Given the setup was not really up to the mark, but let's give it one more shot. Can we switch to demo? So Sebastian did show, correct? He was showing the code, which was mostly about, giving a command to a voice assistant saying that, okay, shop for something. And then it was trying to identify a text, and it was calling one of the API, which was from eBay, I believe, and then trying to basically fetch some of the result and send it as an email. I've tried to mimic similar behavior. And let's see if demo gods are with me. So what I'm doing at this point of time, I'm just going to ask for maybe shop for something, correct? There's a Mother's Day is coming up, and I won't be in time for it, and I want to send something to my mom. And I was thinking, what could be an interesting thing? Apparently, the smartwatch is a big thing. So I thought, okay, maybe let me kind of gift her a smartwatch. So let's see if I can find a smartwatch using my voice kit. Hey, Google, shop for smartwatch. Cool.
Done.
So if you look at what it did, it basically kind of recognized my voice or my command, and kind of connected to that particular service and displayed some of those smartwatches available for me to kind of purchase it. Now at this point of time, I could take this output and either send an email, like what Sebastian was mentioning, or if I have a smart display device, I could basically post it there, or kind of give a nice visual list that, okay, these are some of the things, or I could kind of engage in a little bit more conversation with that. Can we move back to slides? But there are tons of things you could do that, correct? What I was trying to emphasize here is that, there's a lot of things possible with the voice that you could play around with it. You could also not just look at the software as a one side of it, but you could also experiment with some of the things on hardware. So let's say we have seen people kind of taking the old toys and kind of putting the voice kits or some of the other AIY kits into it and revive the bodies or kind of bring life to those toys. We have seen people kind of build customized shells for voice kits. There are people who have kind of done device remix, so kind of giving voice and kind of vision to a Roomba vacuum cleaner. So you could tell them, okay, no, don't go to this side of a house, but go to the different side of house section. Or you could kind of create completely custom voice actions. So tons of things is possible. If you want to know more about what is there, you could kind of follow us on Instagram or Twitter, or follow the discussion on Reddit with AIY projects. With that, I'll invite Bill to know more about what's happening on Vision Kit.
Thank you. Thank you, Dushan. Is my voice okay? All right, let me continue with the second product line in the AIY product family, which, as you can see, is the Vision Kit. The Vision Kit is a relatively new product, and it's just being released end of last year. And we had a new version update the first quarter of this year. So the latest version is 1.1. As you can see, launched in December of last year. It has the latest Raspberry Pi Zero, and the WH, the header, it's soldered on the board. So it doesn't have the problem in the early version that you have to solder the pins yourself. It's much easier. It comes with the Raspberry Pi camera version 2, and the Google-made Vision Bonnet circuit board. And that's where all the software, hardware, artificial intelligence, where Google put into the product. It's on the Vision Bonnet board. The most unique things of this particular product, it doesn't require you to connect to the internet. You can work with a vision recognition software on the box by itself alone. So before we start, let's go through the list of materials that Dushan did for the voice kit, a similar thing. In terms of the hardware, as I mentioned, it has the latest Raspberry Pi Zero board and the camera. And Google produced this Vision Bonnet. This Vision Bonnet circuit board contains the Intel vision recognition processor, which has all the computing power to help you do the vision recognition. In addition to that, it has the camera support, and it has the connections to the Raspberry Pi cable connector. It also has the general purpose input-output, so-called GPIO connector, allow you to do more things, which I'm going to cover shortly. And also, it has the crypto chip on board, help you to encrypt the signals, okay, to add more securities in terms of the application. Then on the software side, and it also has the button, as well as the cardboard form, allow you to fold into the device. On the software side, the operating system is the same. It runs on the Linux Raspbian operating system. We include a TensorFlow, the so-called Inception and MobileNet software. It's on the device, which allow you to build AI models to work with this device to do applications in AI. It has the built-in software for facial recognition, as well as the general object recognition. So all these software is on the device. You're ready to use. And in terms of its component, let me get into a bit more detail because this is a relatively new product. On the hardware level, at the bottom, which is the Raspberry Pi Zero with the head soldered on, as I said, the Raspberry Pi Zero has the built-in Wi-Fi and Bluetooth support. So you can connect the internet if you want without a cable with Wi-Fi connects to internet. It has a GPIO connection, which allows it to connect directly with a flex cable to the Google Vision Bonnet circuit board. That circuit board with additional flex cable connects to the Pi camera, as well as the additional accessories like the LED and the push button and the buzzer. There's a piezo buzzer on the device that as your application necessary, you can have it generate sound. Then on the software side, it runs on the same Linux Raspberry operating system. And the program runs is all in Python code. So it has the Python interpreter on top of that. And at Google, the software we put together contain 3 different modules, if you will, in terms of the vision process. The first is the TensorFlow module that does the vision inception. Second, it has the facial detection software. And the third has the object detection software. So with these software on board and with all this hardware, and you, through the API calls, write your applications interface with these components. So this is how everything put together. Okay? And then let me go through the same process Dushan mentioned in terms of the voice kit. So first is you assemble it. In terms of assemble, very similar. You bought the box, it has these parts, cardboard, whatever. As you can see on the screen, in terms of the process building is relatively easy. You basically hook up the Raspberry Pi with the Vision bonnet cable, with that orange color cable, hook them together, stack them together, and then fold the car box, insert this module into the middle, almost like you put the engine in the car, as Dushan mentioned, right? Hook up the button, and that's it. I can build this thing. First time I built it, about 40-some minutes. Second time I built it, it took me only 20 minutes. So it's very simple. In fact, I have a plug for myself. I made a video tutorial of how to assemble it on YouTube. So for those of you who don't want to read the instructions, you can watch the video. Okay? But it's very simple, very easy. Okay? All right, so to assemble that, congratulations. In less than an hour, you'll be able to just build a device like that. Okay, in terms of setup, this is very simple. As I said, this does not necessarily need to hook up to the internet. So the connection is all you need is just a power supply. Have a power supply connects to it, and you're ready to go. And because of the facial recognition software we're building into the device, after you power it up, it will automatically run the facial detection software. So right now, on the desk, I have this Vision bonnet with me. And as you can see, the top LED blue light, the button is lighted up. Now, if I point this to my face, as you can see, the blue light indicating the camera is capturing my face. If I show to the camera with a smiley face, a happy face, the light color of the LED will change to yellow. And if I'm showing a frowning face, it will go back to blue. So let me demonstrate this. Can everybody see, right? It changes the color. Now, let me say, this is not some kind of a magic. It is AI at working. So what happened, it is a software inside with the AI TensorFlow model with the facial recognition. Actually, I'm going to get into in a minute, to make a facial recognition software just like that. So there's not much of a setup. Just power on, hook up the power, and you can do facial recognition. This demo is called Joy Detection. Okay, it's a part of a product we ship with the device. All right, so assembly very easy, setup is very easy. How to make your own solutions? Okay, there's a lot of software you could do, and let me do another demo. So please switch the screen to the output of my other device. So as you can see right now, I'm running the Raspberry software operating system, and there's a window showing the software. Let me by starting a simple demo, which is the object classification. So I'm going to start with demo, and as you will see on the screen, on the right-hand side, it will have the camera, the video image coming, captured by the camera. And on the table, I have an apple and a banana, and also a Coke can, just some random object that I put together. Now, as you can see on the left side of the screen, there's an output stream out starting putting on the screen, which is by the object classification software that we put on the device. Now, I'm going to explain all that in a minute. But first, let me do a demo. Let me just point this to banana. And you should see on the left hand of the screen, it will say, it detects this object, a banana, I hope, right? Now, if I point this to an apple, not only it will recognize it's an apple, in fact, it should say Granny Smith. it actually recognizes the type of the apple, okay? And I tried it earlier. I pointed this Coca-Cola can. I don't know what it will say. But earlier, it was telling me, I think it's a punching bag. Well, lots of punching bag, it's red color. It looks like this. So let me stop the application and let me make this window a little bigger. And as you can see on the left side, the first column number, it is the object recognition, it recognizes it. It says it's a banana. The number after that is the so-called confidence score. How confident the AI think this is banana, or similarly to an apple, which is Granny Smith's apple, okay? So this confidence level tells you the recognition part, whether it thinks it truly is the object it detects. These numbers, these kind of feedback from the software, you can use to make a lot of applications, okay? Let's switch back to the slides. So this image on the screen, as you can see, very similar, right? It recognizes the object along with a confidence score. You can use this number to help you design your applications. So exactly what can you do with a vision kit, the AIY vision kit? Well, number one, as I said, you can see already does the object detection, and it has a facial detection. This is all software built into it, and through API calls, you can leverage these. It has the automatically be able to take in photos, videos, and send it output to your application. It has the image classification, which you just saw, be able to tell apple and banana, and a whole bunch of other stuff, okay? But most importantly, right, as the Joy Detect demonstrated, you can run your own AI machine learning software in this device by building your own customized TensorFlow model, okay? Now, some of you may be thinking, how do I do that, right? It's a bit confusing in terms of building a TensorFlow model. That's very powerful stuff. How do you do that? All right, so let me introduce to you the process of how do you do your customized model. So first of all, the first number one, every machine learning model you build in TensorFlow, you're building a model to train, right? So specify and train your own model is the first step. And the second, just like any other TensorFlow model, you get the end results, you do a so-called export model to a so-called frozen graph, okay? Any model you can generate a frozen graph. But a frozen graph has its own format. That format does not understood by the Vision Bonnet hardware, okay? So somehow we need to make a match. And that match is done, the next step is the so-called compiler. Google provides this so-called Bonnet model compiler. You take the frozen graph binary code and compile and run the compiling through the compiler code, you generate a so-called your own customized computer graph, okay? So the artifact-wise is in the end result, you're going through these three steps, you have a binary file. That file defines your machine learning model. Then on the hardware side, of course, we have a Raspberry Pi, we have a Vision Bonnet. Raspberry Pi has a Python program. You use the API calls, you send this computer graph, if you will, to the Vision Bonnet. So in the next step, you write some code. You can look at our tutorials and the example models. Calling a model function basically is send this computer graph into the Vision Bonnet. In this particular case, the computer graph and the Vision Bonnet, they match. They understood, okay, what's going on. And then you have a camera coming a stream of inputs. Those inputs are coming as a binary number. But because of this computer graph, we arrange these inputs into whatever the machine learning tensors, okay, which basically is a bunch of multidimensional arrays, okay? So now next step is you need to match this tensor, a bunch of arrays, to the image with your model. And this is what we call do this computing. Basically, the step is you write a program, you have this Vision Bonnet hardware, and does the calculation, and will send the signal to the output. And here's the code, okay? How do you define your face object, okay? As you can see, the face object was defined with the bounding box, the face score, and the joy score. You write an arguments code like that, and this is your structure. You send this structure, okay, and say, in my model, I need these to have 4. And these 4 numbers matches my machine learning model. And finally, in your application code, you just say, let me get results from this tensor, whether the joy score, the face score, whatever, and you take that into your end result. And you can make a decision and say, if the score is based on some number, above some number, change my color line, okay? So this is exactly what you do in terms of using your own machine learning model with the Vision Kit. All right, so with that, let's talk about extending your project, right? We talk about the software, but how about hardware? On the AIY board, there's the red circle area I pointed out. It has additional GPI pins. With those pins, you can control output. Turn on the lights, turn on the fans, sending out, making some noise, whatever you could do. So with these things, you could expand your project, and with that controller on board, you can do a lot more things, okay? So hardware-wise, as a maker, we could do more things. All right, so we've gone through all these. We talk about the assemble, how do you set up, and how do you do your own things. And most importantly, I want to say, to use AIY, the power of AIY really it is connected to many of the services Google provide, right? Like Google Assistant, like TensorFlow. You want to leverage all these power of service behind you. And AIY, we are part of a global open source community, right? We publish this on GitHub. We work with Raspberry Pi Foundation. We work with Hackster. So immerse yourself with the online maker communities around the world, okay? And this is the part of the fun of building makers, AIY. I want to take this opportunity to tell everybody, for the audience here, those of you from the US, okay, you could join a contest going on right now, organized by Hackster with the Ministry of Education in China. It's so-called Young US-China Makers Contest. The winners will get an all-expense-paid trip to China. So those of you in the room, you are American makers. Please join this contest. And more details on Hackster website. All right, the key takeaway from our talk today, what Sebastian and Dushan mentioned in their part of the talk and mine, the key takeaways, resource-wise, the global AIY website is this address, AIYprojects.withgoogle.com. The kits can be purchased right now at the Target store in the US. And also, next weekend in the Bay Area, there's a Makers Fair. Those of you who are in the area joining the Makers Fair, you can get the kits from the Makers Fair. Learning using Raspberry Pi, using Python programming is a part of the thing that you need to get yourself involved to expand your applications. And using TensorFlow machine learning model to really build the power of AI into applications. And that's the power of AIY. And finally, to summary, and I would say call to action, the things you guys could do, right? Everyone could do. Get AIY kids and start building and have a lot of fun, of course. And learning many Google services. At Google I/O, we have sessions on Google Cloud, on Google Assistant, on TensorFlow. Please join and learning a lot of those knowledge and skills. And get a lot of different sensors, controls, hook up to the GPIO ports on those devices. Okay, you can build a lot of fun applications and leverage your AI capability. And then lastly, joining online communities. We will very soon publish a global AIY model exchange and put your application on that, share your knowledge with the global developer communities. So with that, along with Sebastian and Dushan, we want to thank you for coming, join our session today, start your AIY journey today. Thank you very much.